Thank you so much for joining us today. My name is Wallace. Sitting with me here is Orion. Let me tell you a little bit about Orion. Good job, Scott, pronouncing his last name. It's Bielefeld.
That's a rare talent.
It is, extremely. Thanks for joining us today. Let me tell you a little bit about Orion. Orion is a cloud ops engineer in a group called AWS Managed Services. And I'll tell you a little bit about what AWS Managed Services is here in just a few minutes. Orion speaks fluent JSON, and Orion taught me two new things this week that I thought were pretty interesting. One was what semaphore means to talk to people with flags. I never knew that. And also the fact that tomatoes and potatoes are a New World food that was only introduced into Europe in the 17th century. Never knew that. That's the kind of guy he is. So, Orion?
Thank you for sharing that. I mean, it's really important for us all to share the things that we've learned recently. No nightshade for having picked up some new knowledge. Wallace has been a really great mentor for me since I've joined AWS. He came here with decades of industry experience, and he is working every day to forget all of it because we're moving on to faster, better practices and a whole new DevOps world.
Exactly. So, hey, thanks. Let me tell you about today. The two of us spoke at reInvent last November, and it went pretty well. And when we closed out that session, we asked the audience if they wanted to hear more about the cloud ops topic that we spoke about. And the answer was a resounding yes. We got a lot of replies. So here we are doing our first office hours to talk a little bit about cloud operations and the work that we do. So how do these office hours work? Well, here's your typical definition of office hours. And, back when I was in college, the professors would do office hours, not that I went, but it was an opportunity for people to ask questions, I guess, I've heard.
So the rumors go.
What we decided to do was accept questions from people during their registration. We took a little bit of time to look up some answers and formulate some responses. And then that's really what this session's all about. It's about sharing information regarding how we do cloud operations in our space. So you've already done your job. You've asked some tough, thoughtful questions. Now we are going to go ahead and answer those. We've reached out to some people for some help as needed. And then with that, let's go ahead and jump in and let's take a look at the first question.
Yeah.
This is a good one.
Yeah.
Oh, I'm sorry. Before we do that, my mistake. I need to tell you a little bit about AMS. That's the group that we're in. It's AWS Managed Services. And essentially what we do is we provide enterprise customers the infrastructure cloud operations so that they don't have to deal with that undifferentiated heavy lifting of really what that's all about. And the way it works is, if you look on the left-hand side of your slide, we take AWS services and management tools, and then we've built a platform on top that does a lot of automation and other tooling around monitoring and logging. And then working with us are customers and or their partners who do the work around the application development, deployment, management. So we really run cloud infra for customers. And if you look at the right-hand side of the slide, those are just some of the activities that we perform for customers. Things like incidents, break fix, alerting and monitoring to make sure that things are running well, patching, backup and restore. So that's just a little bit about AMS as a group. And this is what we do every day. So that's why we're here to talk to you a little bit about cloud operations. Shameless pitch. If you're interested in AMS, reach out to your AWS account team and they can point you in the right direction to find out more about our group. Enough of the sales. So how did we choose the questions that we're going to address today? We had about 300 people register for this webinar, which is great. We love it. Out of those 300 people, there were about 150 questions that were asked. A lot of you said, hey, I just want to hang out and listen, which sounds good to us. But what we did is we went through those 150 questions and we categorized them into buckets. And then we just looked for some common themes in the questions and really tried to answer the questions that addressed most people's interest, so to speak. So having said that, we're not going to be able to answer all the questions in this session, but we are going to make every effort to answer them at some point directly. So with that, we'll go ahead and take a look. Is it time for questions now?
Yeah. Do you want to field the first one?
I think I'll take the first one.
Okay.
Yes, this session will be recorded. Scott kind of ruined it by telling you that in advance, but thanks, Scott. Yes, this session will be recorded. We highly encourage you to take a look at it afterwards because it'll be that good.
Yeah.
All right, let's move on. I want you to take these.
These look much easier than that question. So let's hop through and just tackle these straight out. The first question that we have is, how can I use security groups to manage traffic through network load balancers? And this is an interesting one because, as many people who've worked with AWS and networking will realize, you can't directly attach security groups to network load balancers. But there are some tricks to get around them if you're trying to open up the ability for a network load balancer to send traffic into your instance that has a security group on it, and you want to open a rule for that. What you can do is you can find the network load balancer, and you can search for Elastic Network interfaces that have its name in it. And you'll find that there's actually an ENI that gets posted into your VPC that has a static IP address in the private address range of that VPC. And since it's a network load balancer that's managed externally by AWS, that IP address won't change. It'll be stable. And so what you can do is whitelist that /32, just single ENI IP address, and that will be one that you can trust traffic from on that load balancer to allow traffic into the instance going forward. Next up, what are some considerations for using auto scaling groups? When I'm dealing with auto scaling groups, I think a lot of the thought and care that I spend comes around termination and termination policies. There's a nifty pattern that I've seen come through a couple of times where somebody will use an auto scaling group in order to facilitate like a single instance standalone EC2 application, but they just want it to come back online if it ever fails out, and they want to regenerate that instance. This is a really useful pattern, but it has some operational overhead that you want to be ready for before you tackle using auto scaling groups in this way, or really most ways. And that really comes to the question of what happens when you terminate that instance. So if an EC2 instance in an auto scaling group is terminated, that can be bad if you have static data on that instance. That includes, for example, a database that might have had updates since it was initially launched. And you want to make sure that you're not going to lose those. So make sure that the use case really fits to what you're trying to do. And then additionally, once you've handled the fact that your instance is stateless, you know that you're not going to cause any damage like that, you can... you will have to go and deal with additional changes that will go to that instance following on. So you'll have to have some patches that will be applied for security reasons and compliance reasons and functionality reasons. You're probably going to want to redeploy your application to it at some point. If you're on an EC2 instance, it's really straightforward. You go and do it however you like. On an auto-scaling group, if you apply updates to the EC2 instance in that auto-scaling group, and then it cycles, you're going to lose all those changes. You're going to revert back to where you were at before. And so what you want to do is bake a static AMI, and then you'll update the auto-scaling group, launch configuration to launch from that AMI, and then you'll trigger a cycle on the instances there. That's what we generally term as static replacement, and it's a really good DevOps strategy. But it implies a certain amount of operational readiness that you want to make sure that you're ready to tackle before you jump off that cliff. The last thing that I want to talk about in auto-scaling groups is, again, about termination. And this is just a really important gotcha to be aware of. Auto-scaling groups has their own termination policy. And if you have EC2 termination policy or termination prevention on an instance, that's not going to stop auto-scaling from dealing with it if it's a part of an auto-scaling group. So just make sure that you throw the auto-scaling termination protection on an instance. So you want to make sure that it doesn't get torn down as opposed to the EC2 one.
Here's a quick question. Can you use hibernation as a termination policy with an auto-scaling group? Put you on the spot.
I don't think I would follow that pattern. I'm not sure if you can, but I wouldn't use that in that way. I don't think that's the intent of it. And you might, this is kind of a world of ops question. If you're the only person ever pushing buttons in an account, a lot of ways that you can use these services make a lot of sense. If you're going to deal with other operators that might be doing other things and not really understand the change that you just made, then you might find yourself in a situation in which that's going to lead you down an undesirable configuration. Good question, though. If we're good on that, I'm going to hop onto the third question, which is that we want to use AWS Auto Scaling for automatic deployment and regeneration, but I have custom scaling logic that's not supported. What's the best way to make this work? So I've seen this in a couple of ways. There's really two categories of solutions that you kind of want to think outside of the box on for AWS Auto Scaling. The first one is if you've just got some secret sauce auto scaling going on that's hard to deal with, and you don't want to write it in, put it into the auto scaling logic, or it's not going to be supported by that logic, and so you have to facilitate your own system. What you want to do there is take advantage of some of the auto scaling APIs and essentially disable the automatic scale in, scale out. And then you're just going to run your own logic and then call the put desired capacity API to launch instances or to tear them down pursuant to whatever logic you have on your backend, deciding how many instances you want in your auto scaling group. The second interesting deployment that I've seen with auto scaling groups where somebody had a really specific use case is where they had some connections they wanted to make sure they never dropped. And so they wanted to do connection draining, or for other reasons, they had a lifecycle question on the instances that they're managing through external logic that can't be propagated out to auto scaling through simple things like health checks or basic metrics. They want to make sure that when they want to scale down, the correct instance is pulled out. And there's a trick for that. Again, you're going to want to disable the automatic auto scaling and then use put desired capacity calls. But then in order to make sure that you're dealing with the right instance there, you want to use the terminate instance and auto scaling API so that you can pick the one that you know is healthy to drop out and make sure that you don't interrupt any other connections. I think that's the only ones that I have here for network and auto scaling. You want to move on to the next set of questions?
I do. Let's take a look at the next question. That was good. Good job.
Thank you. I appreciate that.
Let's take a look at the next question. Did it pop up? There it is. Oh, I think
we get this question.
These are real questions, so we wanted to answer them. So
yeah,
you should take this one.
Yeah, I mean, according to the great sage Douglas Adams, this is a question that we should all know the answer to. It's 42. Excellent question. Yeah. But I think after I've handled the hardball there, we're going to kick it over to you to do some CloudFormation.
Yeah, let's talk a little bit about CloudFormation. So we got a bunch of questions about CloudFormation, and I wanted to tackle a couple of these. I'll say it at the outset, I'm not a CloudFormation expert. I've done a bit of work and training in it. So what I did is I reached out to my good friend Alex in Sydney. Alex, thank you. And here's some answers to some great CloudFormation questions that we got. First one. What are some best practices regarding CloudFormation template management? And this is something I thought a lot about when I was going through some CloudFormation training myself. The first tip is manage your CloudFormation templates the same as you would any other code that your organization develops. Because if you think about it, CloudFormation is infra as code. So this means if you're doing any versioning, any repositories, check-in, check-out, any of those collaborative things that you would with other code, you should do the same with CloudFormation and treat them the exact same. Along the same lines around template management, I wanted to share some CloudFormation best practices. There's a link here, so if you're watching the video later, pause and go check out this link and then come back. There are some really great tips here. The documentation around CloudFormation is really great. I will admit, at least for myself, it's a little bit tough getting started if you're new to this space. But once you do get started, once you figure out how the documentation works, it's actually really, really good. So check out that best practices link. The other thing is to use a good text editor so that when you're using either JSON or YAML, you can go right in and see any syntax errors. I'm a YAML guy and a lot of, JSON boy here. He speaks curly Q's and brackets and trailing commas and all that kind of stuff. A good text editor will let you find those immediately. And I know I struggled with that, which is why I cheated out and went the YAML route. And then the last thing I'll talk quickly about on this one is performing these static tests. There's a link here to one of our AWS partners. There's a pretty cool little tool that you can use that'll do a static test, which means it'll test your code before you go deploy. And in this particular one, it's looking for things like excessive security permissions around, I think, either IAM policies and security groups.
Yeah.
And then it also checks for things like encryption options that you may have turned on that you forgot. So it's a pretty good idea to do this kind of static test before you actually go to deploy. If you don't do this, you may find that you deploy something and then that's when you find out that your security is a little bit more lax than you want, and that could be an issue.
Yeah, I'm a big fan of the tests that run that repo, because really what they're doing there is just a little bit of security and operational readiness checks.
Yeah.
And it's a really nice property of having infrastructure as code like in CloudFormation, because suddenly you can start looking at those best practices checks as a static analysis against a document, which is a lot easier than doing it as a dynamic interpretation of a bunch of resources all over the place.
Thank you. I got this next one about using, so how would I go about creating a training environment where I could use, do an auto deploy, an auto tear down, maybe some applications in there for students to play with. And again, I thought, when I read this, I thought CloudFormation is a great solution in here to go ahead and build out that environment. I've included some helpful resources to get started. I mentioned a few minutes ago about when you get started with the documentation, there's a link here for the EC2 reference guide. And when you're getting started with CloudFormation, one of the first things you want to do is find the reference guide for the resource that you want to work with in CloudFormation. And then from there are both JSON and YAML templates and guidance to tell you exactly the different options that you have within CloudFormation for that resource type. So what we would do is we would just literally copy and paste that into our text editor and just start going through and choosing which of those options we want to use and filling them out as we go. So I pasted in here the EC2 instance reference is a great place to start. I also wanted to highlight that there's some EC2 template snippets that are pretty cool to look at. Depending on the scenario, there are dozens of them. So depending on the scenario that you want to work with, there's a good chance that there's a template snippet that's already addressed at least 80% of what you're trying to do, and you just need to tune it for your application. So I highly recommend the template snippets. And then lastly, I threw a link in here. A lot of times in a training environment like this, you might want to throw an application into the stack so that when you're doing work and through your training environment, that you don't have to deploy the apps either. There's some really simple ways to deploy some simple apps using things like user data and some other ideas. If you look at this last link, it'll tell you how to take the CloudFormation that you had built for the infra and then throw some simple apps that might be good for a training environment that you could tune for your use. Good?
Yeah.
Let me go to the last one here. This one, is it possible, these are real questions, is it possible to create a CloudFormation template to automate the creation of VPC tunnels over a direct connect and then include pulling the BGP configuration files? Pretty involved, detailed question.
Yeah, it's a complicated question.
Yeah, it was. So the answer is yes. And it does assume in this case that you've created some things in advance. In this particular case, the direct connect or the public virtual interface. So what I did is I threw a link in there to help you out if you're trying to create your first public virtual interface. There's some really great guidance right there. And then for the other part, if you look at the EC2 resources that I've highlighted here, so in the resource section of your EC2 resource in the template, if you use these features right here, you can do some of the configuration around the VPC and the direct connect and the BGP. I'm not going to go into these in detail, but I'll just leave this up here for a minute so you can either grab a snapshot or pause the video here and look. But these items right here within your CloudFormation will enable what you're trying to do in this place.
Awesome.
Anything you want to add there?
No, I think that's really good.
Good. All right. We're doing good on time. I'm going to keep moving forward. Let me just see if there are any questions. I'll tell you what, I'll advance and then I'll check out questions while you're talking because I don't want to listen to you.
Yeah.
Let's look at this question here. I just want to listen. Do I have to ask a question? We got this a lot.
Yeah.
And I thought,
in a couple different formats.
I thought this was pretty clever. So yes, just listen. That's great. Do you have to ask a question? No, but kudos because you did.
Yeah.
So
you answered your own question.
Thank you. All right. So moving on. let's talk a little bit about security. I'm going to hand this one over to you.
Yeah, and I want to put a little bit of a caveat on this first question because I don't work for the guard duty team, and actually I know that they've done their own office hours, and so I don't want to step on that. But this is just a quick 30,000 foot view of how guard duty generally is operating, in case you're interested in it. And it's a really fascinating service and it's providing a lot of value for customers. The basic model for how it operates is that it takes CloudTrail logs, VPC flow logs, and the DNS records of requests made in your account, and then it applies both static and machine learning analysis to those logs, and comes up with what are called findings, which is a standardized Amazon format for different issues that have been found with the security context. So you can see that some of the static findings would be, let's say, communication with an external IP address that's known to be malicious, or access to Tor infrastructure is going to be a pretty static configuration that anytime VPC flow information, flow logs indicate that one of your instances is talking to a Tor node, you'll get a finding for that, which is really useful if you think that something may have been compromised and is now communicating over Tor or anything else. On the other side, and still going from a network security perspective, there's the machine learning analysis, which will take all of the information of the communications from your instance over a period of time. And then when it finds something eccentric from that instance, it'll then give you a finding about that. So if you've got something that has never sent anything on port 25 before and suddenly it starts doing that, you'll get a finding letting you know that, hey, this is something that's unusual. Maybe it's nothing, maybe it's totally fine, maybe it's the result of a monthly activity, but it's something you should take a look at. And it can provide a lot of really good value in behaviors that are otherwise quite difficult to track down. The consumption of guard duty is also something to address because guard duty has a console. I highly recommend poking around in it. It's very easy to use. But ultimately, you may want to consume the guard duty data and the finding data into your own system. And so it's important to know that guard duty posts to an SNS topic, and you can simply put a listener on that.
There are actually a lot of people who do that. They take CloudWatch and all these others and then push them into a single dashboard so they can action them, rather than going to the different consoles. So
right, and then once you have that, you can start applying your own logic for, I know that this is not an issue, but it might come up in guard duty, or I know that this is more of an issue, and I definitely want to escalate and trigger immediate response whenever I see this particular kind of finding. Moving on from guard duty into the next question. The question is, what's the best way to leverage organizations to secure my accounts? And I don't want to go ahead and tackle something that somebody else has a really good answer for. And so I'm going to send you to some external resources, which are AWS Landing Zone and AWS Control Tower. These are a couple of prescriptive designs. They're patterns of really good ways to solve exactly the question that you're asking.
Why don't you talk about Landing Zone for just a minute, what that means?
Yeah, so AWS Landing Zone is a model for making a multi-account structure that isolates different parts of the problems that you're trying to solve into accounts that are really just trying to solve that problem. So you'll have a master account that is capable of administering all of the other accounts, but you're not going to go ahead and run your application inside of that, because your application might need IAM profiles, and you don't want to just handle dealing with permission delegation and making sure that nobody ever steps on anybody else's toes. It's challenging, and the best security boundary that I've found is the account. And so you take advantage of that security boundary by saying, I'm just going to keep my organization master account in its own place, and then I'm going to have an application account that's going to run its applications. And then I've got, let's say, a piece of infrastructure that has some billing costs associated with it, and I don't want to run 5 copies of that. I would like to run just one. And so I've got application A running in its own account and application B running in its own account. And I also have a shared services account that is connected to those accounts through VPC peering and is providing that service to all of them while still retaining all of the security advantages of the account boundary. And AWS Control Tower is actually a model for the automatic deployment and administration of systems like AWS Landing Zone. They really work together, and I strongly recommend that you go and dive on those public docs because they're really high quality. On to the last question on security. How can you give an instance profile permissions to a Lambda CI/CD deployment server without giving it IAM star access, which is a considerable security risk? So this is a relatively common pattern, actually. You think I need to be able to make a role and I need to have permissions for it, but I don't want it to be able to define its own permissions because I don't want to have a CI/CD server that has permissions to do anything. And if you have IAM star, you have permissions to do most anything. So the model for how you do this is you'll predefine your IAM policies and the IAM role. And then the API that you want to solve this problem with is IAM pass role, which gives permissions to that CI/CD server to delegate that role to another instance. And this is an interesting one because you can have a role that has even more permissions than the CI/CD server in some cases, but the CI/CD server doesn't have permissions to that itself. Only when it provisions other infrastructure can it launch something with that role. I'm a little bit of an IAM nerd, so I might go into a couple of the tiny bit. I might go into a couple of the nuances of this one because you can get some really good value out of this API. There's a couple of things that you can do while you're passing roles. One is you can put a condition key on that role that says you're only allowed to do this so long as, and what you do there is you put a permissions boundary on it. And permissions boundary is a special kind of IAM policy that is taken along with the policies that grant permissions on a given principal, and you get the union of those. So if one says, hey, you can do EC2 list instances and EC2 describe instances, and another one says you can do EC2 describe instances and EC2 run instances, if you apply both of those, you will only get the describe because that's the only one that they both specify. And so what you can do with this pass role is you can have something that allows there to be permissions, but they will always be a subset of some other permissions. And so that can be useful for when you have more dynamic IAM policies that you want to make, but you want to make sure that you're not going to open up some APIs that you didn't want to enable. The other trick that you can follow with this is something called an assume role statement. And this is, or an assume role policy, sorry. And this is a IAM policy that you pass along with the SDS assume role call that is made by an instance when it's, or any resource. And it's treated exactly the same. So it takes the union of those two permission sets. And so if something's going to get denied out, then it will be, then you can control it at assume role time. And so you can have a role that has more permissions than the infrastructure actually is launched with, or actually is used during that session. That's all I got for security.
So let me pause for a second. It feels like we're throwing a lot of references to public information and documentation. We actually wanted to do that so that you'd have something to go look at after we're done. Plus, some of these answers are really, really big. And so what we wanted to do is at least give you a heads up or a starter path down to the solution, talk a little about it, and then leave you something that you could go look at and get the more full answer. There's just not enough time to dig into every topic in this session. Yeah,
and I want to be really clear about something. All of these questions go through the same problem-solving pattern that I use every day to do my job, and Wallace does as well. Is we look at these, and probably our first stop in most cases is AWS public documentation. There's a lot of public documentation out there. It's really high quality, and more often than not, the question is just, hey, where can I find that? Yeah. Where's the solution for that in public docs? Yeah. And so we're pointing you in the right directions in a lot of these, and hopefully that's something that helps you all. I know that one of the top skills that we develop in operations is the ability to find the right public doc. It's high quality.
And I should mention that the rapid iteration in AWS, the docs are changing quite often because they're getting updated every time a new feature set's being released. So. Ready to keep going?
Yeah. Let's keep on
going.
So
let's talk a little bit about continuity. I'll just start this, and I'm going to hand it off to you and say that when talking about continuity, we tried not to get into the architecture conversation because we're really ops people, but you'll find out pretty soon that when talking about continuity, there's an architecture or a design for continuity, a design for availability. And then there's also the response to when things go wrong. So we're going to touch a little bit on both of those, but I just wanted to get that out there that two ways of thinking about it: avoid the availability issues up front and maintain continuity, or how to react from it. So with that, let me just toss it over to you.
Yeah, let's just tackle more questions. So this question is, how do I give my customer a static IP but still do failover full stack blue-green deployments? This is a fun one because this kind of gets into like some mismatches of best and worst practices. We all know that static IP addresses in public-facing applications are kind of an anti-pattern. We have DNS for a reason. It's supposed to solve this problem. But sometimes, everybody's got a couple of the old applications kicking around that they take a static IP address, or nobody can agree on how to do the DNS delegation. So there's a hard-coded IP address somewhere, and we just, got to operate through it. The solution for this, if you're on the other side of that, where you've got static blue-green deployments, sounds like you got a full CI/CD stack going on, is that you want to front end that stack with infrastructure that will keep a static IP address. And the piece of infrastructure that handles that is going to be an NLB. So network load balancers, as we were talking about earlier with the internal IP addresses, also keep static public IP addresses. And the only reason that this would change is if you tore down and recreated the network load balancer. Otherwise, it should be static and safe for this particular type of deployment. An additional complication that you run into sometimes is that the solution that you're looking for actually wants a elastic load balancer, because you need some of the layer 7 features that provides. And when you run into situations like that, the trick is actually that you can stack them. So you can get all the advantages of your elastic load balancer with a network load balancer on top of it, and then back end that with your instances that are running in a full blue-green deployment stack. This is a really great question. And the next one here is a little bit more philosophical. What is the best strategy for disaster recovery management? So disaster recovery is really a question of like multi-dimensional distance. You want your recovery systems to be distant from your infrastructure, both geographically and chronologically. So if a data center is impacted or an AWS region has an outage, you want there to be infrastructure in another region that can handle that. Additionally, if you go and import some data, including little Bobby tables, and you drop your whole data set, you're going to want something from last week that you can restore from. So it's important to recognize that disaster recovery management follows not just space, but time. And when you're...
Sounds very Star Trek.
You ask a philosophical question, you get a philosophical answer.
Keep going.
So there's a lot of answers for this. The basic ones are in many ways the best. If I want a data set from last week, I'm probably going to produce a static image of that data set, and then I'm going to throw it into an S3 bucket. And I'm going to put versioning on it so that I have that data set preserved chronologically, so I can go back to last week when I find out that I've lost all of the data that I care about this week and nobody alarmed on it. The other side of that is deploying it to another region. And for this, I kind of want to talk a little bit more about the infrastructure itself as opposed to the data. So one of the tricks that you can do with infrastructure is that if you've defined it, as we discussed earlier, as code and CloudFormation, you can then deploy that into another region. And with only a very small handful of edge cases, you should be able to deploy that with no complications, one region to another. And this introduces the third dimension of disaster recovery management, which is cost. We're all paying attention to cost, and one of the big questions whenever you're doing disaster recovery management is, do I have to spend all of the money to store 30 copies of that data, or do I need to keep that infrastructure running so I have a hot failover? And this is always a question that you're going to have to take into account. You're really spending money in order to provide uptime or provide recovery time. It's going to follow that model, and so what you're one of the advantages that you can get out of CloudFormation is something like a cold backup, where you can have everything ready to go, and hopefully you've tested this deployment, but if you needed to, you could spin up another site in 10 minutes or whatever your launch time is without actually paying the money to keep all of those instances running all the time. You can exact a certain amount of cost savings, which is advantageous.
Yeah, so I'll just add to that. The cost is usually associated with the business criticality, and if it's a tier one business critical service, you're willing to spend more money. You're willing to spend the time and effort to have that hot site to flick over to on a rollover. If it's a lower business critical app, then you're willing to have a bit of a time lag where you can just redeploy doing CloudFormation. So the beauty of it is you have different options based on the criticality and your cost and your risk tolerance.
Awesome.
Cool.
Yeah,
All right.
I completely agree.
So let's go to the next set. We're still doing pretty good on time here. Good job. I noticed in the chat online that there were some questions around logging. So you go, I'll look at the logging questions. I think you go ahead and I'll look at the logging questions in the chat.
All right. Sounds great. So the first question is, how do I manage a large aggregate logging database? And that's is a huge question. There's a lot of answers to this. And it really depends on what your business case is getting these logs out. If you need periodic access to these logs or you need to make sure that they exist for compliance reasons as opposed to actually using them operationally, your answers might just be S3 or other long-term storage. Which is a great answer and solves a lot of basic problems. In some cases, though, you need operational access to these logs, and there's two basic answers to that. One is that you can stream it into CloudWatch, which is ultimately backed by S3. And if you need highly scalable log management and you actually need rapid access to that, my personal recommendation is to stream it into DynamoDB. DynamoDB is a managed database service by AWS. The storage costs are higher, and so if you've got a lot of logs, it's potentially going to incur more costs than a simple S3 bucket, but it will give you a lot more access to them on a rapid and dynamic basis. The things to watch out for when you're setting up a system like that is that if you've got some queries that you're going to want to run against it, there are service limits on DynamoDB for the number of indexes that you can search on and filters. So you want to be careful to think about what your queries are going to look like in the system before you go ahead and implement them, because otherwise you might find that you didn't support the query that you needed, you don't have the ability to make the lookup that you wanted, and at that point you're kind of back into the S3 situation where it's really just big static data. You're going to have to download it and parse it yourself. Additionally, I want to just do a quick call out that if you are throwing this stuff into S3, Redshift is a great way to parse that data. But that's kind of its own presentation. And I don't want to dive too far on it. We're doing okay on time, but not that good. Yeah. The next question is actually kind of linked to this one, is how do I get my log aggregation to work across different VPCs without exposing it on public IP addresses? So both of the answers that I gave for how to handle large amounts of logs are really structured around the two different AWS services, DynamoDB and S3.
Let me just jump in. Don't forget about Kinesis and Athena as both a streaming for Kinesis and Athena as a searching. So anyway,
keep going. A really good point. And I actually have a little bit of an anecdote about that in the section on Splunk. So cool. we'll jump into that in a sec.
Cool.
So the trick with all of these services, or both of these services, is they both support a feature called VPC endpoints, which allows you to have an AWS API endpoint put directly into your VPC, so that calls made to it aren't actually even going to go out over public AWS. And this keeps everything in private IP spaces. You can run this even in VPCs that have no IGW or VGW. So they have no route out of the VPC, and yet you can still make these API calls, which can be really important if you have highly secure data or best practices or compliance requirements that require you to isolate this from the public internet. But you still want to have a good log system that allows you to put those logs for further analysis. So yeah, let's go and answer the question you had a little bit about CloudWatch infrastructure data. So the question is, what is the best way to get my CloudWatch infrastructure data into Splunk? And you were asking, what's a good way to stream things through? And the answer was Kinesis Stream and Kinesis Firehose is
Very good.
really the pattern that you'll want to follow here. And I included a link to a blog post by Splunk on exactly how to do this. Actually, that did not make it into the slide. I'm sorry. I will make sure that gets posted out to you guys in the follow-up messaging. There is AWS documentation that you can find if you look for Kinesis Stream Splunk, and it gives a really great pattern that goes, say, from CloudWatch logs that are going to get posted into a Kinesis stream, and then from that Kinesis stream, they come out of a Kinesis Firehose transformed to be aggregated directly into Splunk. And the only other piece that you want in there is some elastic load balancers to make sure that you're balancing the data between your Splunk nodes. It's a really good pattern, and I don't want to dive on it too far, but it solves the problem very well. It's a very well recognized pattern. Shouldn't have too many complications in deploying it. I've seen it work.
Cool. We have one more big topic, then we'll do a little housekeeping break, and then we'll finish up with what we call the rapid fire. Sound good?
All right, let's do it.
So let's do the last big topic on monitoring.
Monitoring. All right. This is a big one. Is it possible to tie cloud monitoring to work in conjunction with on-premises systems? And the answer to that is a resounding yes. So something that you can do is you can put CloudWatch data as an IAM user. So the traditional model for how we want to put CloudWatch data is that we're going to attach an IAM role to an instance as an instance profile, and then that role is going to have permissions to put the CloudWatch data into the metrics that you want or the logs that you want, and you stream it that way. If you have an on-premise instance, which is therefore not attached to EC2, you can't use that IAM role because there's no metadata service just to provide you with the credentials. And so what you want to do there is instead use static credentials. There's a whole thing to talk about in terms of credential management and ensuring that you have good rotations and that you're tracking the use of those credentials, for which guard duty can actually be very handy. But generally speaking, if you have like on-prem, you've just got a rel instance that's running, and you want to get the same kind of metrics that you were getting out of EC2 on that, what you can do is create an IAM user and then take those credentials, put them on the not instance, the computer, and then just tell your daemons that are running monitoring on your rel computer to send the data back to CloudWatch, and that should be an allowed API call with no additional complications. It's a good pattern.
You should move to the next one.
Yeah. So let's hop on to the next question, which is, what are the best practices for monitoring serverless applications? So this is a big category, and there's a lot to go into on it. Generally, when you're looking at serverless applications like something running on Lambda, you're going to come into kind of the same things that you would monitor in a standard web application as opposed to a serverless one. The first thing is you want to watch your errors. So watch out for your 400s and your 500s. A great way to get good metrics out of this is to tie it into an API gateway as a front end, which then is going to stream this data out to you, and you can watch as CloudWatch metrics. Good things to pay attention to in Lambda are P99 and P50 latency on the API gateway side, and then concurrent executions on the Lambda side, as well as total execution time on the Lambda side. Because if that starts creeping up, you might realize that you have some external resource that's running into a limit and slowing everything down, or you might see that you're spiking your traffic up way higher than you should because of maybe some long forgotten for loop or other dangerous practice. And you want to pay attention to that before you start running into the Lambda service limits, or suffer some increased latency that could impact your customers. As with all monitoring, there's a really big caveat to it. It's not enough just to make the metric. You want to test it. I've seen plenty of metrics be produced and nobody watching it. pages that go nowhere is a big anti-pattern. You want to be really careful for it. And so if you're going to go ahead and set up a metric on something, or you want to go and pay attention to anytime there's an error thrown, make sure that data triggers an action. You want to have that go to an engineer. You want to have that go to a manager or a developer, whoever is
or an
going to be
automated
responsible.
remediation, automated diagnostic, something. It's got to go do something.
Right.
Yeah.
And that's really another good point, is that I've been on both sides of the alarm quantity, the desired alarm quantity. You can have too many, and you'll start to suffer alarm fatigue. And when that happens, the efficacy of your response can go down. So you want to make sure that you're not throwing an alarm for any reason other than to trigger a remediation. So if an alarm happens, like you said, an automated remediation or the engagement of an engineer should be what you're following that up with. Otherwise, why are you throwing the alarm? All you're doing is reducing the efficacy of your other alerts.
All right, I have a challenge for you.
Yeah.
You get 1 minute to answer this last question.
How do you deal with sensitive data when tracing? I can do this in 2 words.
Oh.
You don't. The best practice when you're handling log streams is pay attention to what your sensitive data is and extricate it. Now I'm going to go up to the minute. There's actually a really great best practice that I follow, which is every time I'm wondering about how to log things, what I want to log, what I want to make sure I'm not logging, usernames and other sensitive data, passwords should never show up in logs, for example, is I go to CloudTrail. AWS CloudTrail has a really, really good logging story. They are taking a lot of data from a lot of disparate sources, and they're putting it together. And they're answering the questions of what should I log and what should I not log. And so when I'm wondering how I want to log a given event, I try to find its analog in AWS CloudTrail and then see what they put in there, because that's usually a pretty good story on what I'm going to need.
Good starting place.
In order to troubleshoot my issue, and then in order to model what else I might want to add. So
good.
Is that in a minute? Was solved?
We'll call it a minute.
Okay.
All right.
Generous.
So, Scott, let me throw it back to you. You've got some housekeeping I think you want to do, and then we're going to come back and do some rapid fire questions. All right. So, again, these are all real questions we got. There were a bunch of questions about migration strategy, and that is a series of office hour topics that we would love to do. So what I did is I notated the 6 R's. Gosh, if I have to recite them, there's replatform, rehost, retire, refactor, retain, and there's a 6th one. Escapes me. Here's the deal. That's funny. I actually have a picture I'll show in just a minute about what the all 6 really are. Shameless plug for a book by Stephen Orban and also a web blog. Stephen was our enterprise strategy marketing guy. Really great blog on a lot of really great topics, and also wrote a book. All of the content has to do with enterprise. Probably a third of it has to do with migration strategies. So instead of going deep into migration, I'd say go check out the blog and go check out that book. It's just too big a topic to address here, but I at least wanted to point out those resources. How do I go back to the slides? Let's see. Next question is rapid fire. Single instance auto scaling. Why don't you take that one?
Yeah, I think I addressed this a little bit earlier, which means that I wasn't paying attention to when I should be addressing the single instance auto scaling question. But yeah, it's a pattern that we see sometimes, is that you'll want to have an instance for the additional features of auto scaling, like automatic deployment, as well as self-healing. But you don't want to actually scale up and scale out because your application model doesn't support it, or because you simply don't anticipate that much traffic.
You good?
Bam.
We got an interesting set of questions around cloud operations, DevOps.
Yeah.
What's the difference? What are the commonalities? Again, huge topic. I'll start. You finish.
Yeah.
So first of all, I'll say we've done a lot of study in looking at DevOps. We do it. And one of the things I've noticed is that DevOps doesn't have a standard definition that's universally recognized by everybody. So if I walk down the hall here in this building in Seattle and said, hey, what is DevOps? I'd probably get 4 different answers from 4 different people. Here's my take on it. I'm going to split between infra and app. And in the infra space, we're very focused on ops, and in the app space, we're very focused in DevOps. I know that's not, you know, entirely accurate to make that split, but that's the way I kind of think of it. Because this is cloud ops and we're cloud ops engineers, our guys and gals are really focused on infra management and operations, and we have DevOps who are focused on, CI/CD and agile development and rapid iteration of applications into production through CI/CD.
Yeah.
So I've kind of got that split in my head. There's no universal right answer. It's just my opinion. What do you think?
Yeah, I generally agree with everything that you were saying there, except the idea that you would only get 4 answers from 4 different people. In my experience, that's pretty conservative.
Yeah. You get 6 answers from 4 different people.
Yeah, right. If you're going to talk about what a cloud ops engineer is, it's going to involve a certain amount of development. And we were talking earlier about how infrastructure is code, and so it becomes more and more inextricable. The infrastructure becomes more and more inextricable from the code these days, and the definition of where an infrastructure engineer begins and a developer ends is a weaker narrative than it has been in the distant past. And so I think the difference that you'll see in cloud ops is really just that it's cloud focused DevOps engineering.
Okay, you good? So what are skills you currently hope to see in coworkers to allow for extremely productive teams? I'll start. I'll tell you that Amazon as a company has leadership principles, and I know it sounds like I've drinking the Kool-Aid and talking about these leadership principles, but I honestly think that all of our people demonstrate the leadership principles. And I'll just give you a couple examples. Customer obsession. I can't tell you how many times I hear people talking about what the customer experience will be. It happens all the time. All conversations are driven around that. Bias for action, going and doing the things rather than waiting to be told to do the things. Earn trust, ownership. I know you wanted to talk about, you did talk about ownership.
I will.
So if I were looking to build a cloud ops team, I would probably use my web search engine, go to Amazon principles.
Actually, I know this one by heart. It's amazon.jobs/principles.
And I would start there. Learn and be curious is one of my favorite ones. Nobody knows everything, but everyone should know how to learn the thing that they don't know. So that's another one. So anything you want to add to that?
Yeah, I mean, I completely agree. The big questions that we have when we're evaluating our coworkers are really boiled down to or interpreted by the leadership principles, and they really come to the fore. One of the ones that we key in on is dive deep. Is a really big thing for me when I'm looking to rely on my coworkers to help me out. We don't stop at the surface layer, and so when I'm looking at an engineer and thinking that's a really, really great cloud ops engineer, that person has the inclination to really dive down, and they don't stop when they find the implementation. They don't stop when they find the spec. They will dive down and see what's actually happening. We spend a lot of time on TCP dumps, basic infrastructure level understanding, and making sure that we've got as much dive deep as we can. There's the other one that I want to talk about, but I think we can do it as an answer to the next question.
Yeah, go for it. Keep going.
Yeah, so the next question is, what do most people say is most valuable about DevOps 6 or 12 months in? My answer for that is going to be ownership. The really, really great value that DevOps brings you is that nothing ever becomes anybody else's problem. As a cloud ops engineer and a DevOps engineer, you really become a full stack engineer in a lot of ways. Once your application is yours and the infrastructure is yours too, you're working together with everybody else trying to solve that problem. And nobody says that's not my job, which is really the key tenet of ownership.
Yeah.
And we see it deliver a lot of value.
I would agree with that. The last rapid fire question we got out of the real questions that were submitted, there were a few of them around best places to get training. I'll take this one. I'm a bit of a training and certification junkie. I don't know. It's just something I do. So what I've done is I've got a couple, by the way, can they see the slides? So I'll just pause right here. These are the 6 R's. I think there was a question following up in the chat. Here are the 6 R's. There's the link. I'll just sit on this for a second so you can see the link. That's the link that talks about the 6 R's in depth in the blog, written by Stephen Orban. And again, I recommend his book. It's a pretty good read around enterprise challenges, especially around migrations. Here are some best places to get training online. The first place is aws.training. You have a lot of options from AWS and partners on instruction-led or virtual training. Everybody learns differently. Some people like to read docs. Some people like to play. Some people like videos. I like the videos, so AWS training. These other four, they're just ones that I have personally used. One of the CBT Nuggets, Linux Academy, acloud.guru, and then lynda.com. There are others, and I'd love to hear from you if there are others that you have used. These I have personally used, and I found them to be really effective. Passed some certifications based off of it. By the way, we're here in Seattle. If you're a Seattle or a Washington person and you have a King County library card, you can get free Lynda training. You might want to check in your own location, whether your public library system has an arrangement with Lynda. But if you haven't seen it, there is a ton of training, not just AWS and tech. There's a ton of really great stuff out there. I can't speak highly enough about these organizations. And like I said, if you've got feedback on some other trainings that you've used, I'd love to hear about it.
And
go ahead.
One additional source of training is excellent webinars like this one, obviously.
Oh, please.
Yeah.
By the way, I'm assuming everybody here knows about the free tier. So if you don't have a free tier AWS account to go and play, that's one of the first things you should do. If you're at a large corporate organization that's an AWS customer and you've got some sort of sandbox that you can play in, I highly recommend you do that. It's one thing to watch the videos and read the docs. It's another thing to actually do it and go through the steps of doing all the stuff that we're talking about here today. So I'm going to go ahead and wrap this up. You have any final thoughts?
Just well wishes. I think we're going to hand back to...
Well, so first let me just say thanks for your time. We very much appreciate it. Leave us feedback on what was good and what needs improvement, what topics. We love the questions. We love trying to provide these answers. The other thing, last thing I'll tell you is reach out to your enterprise support TAM, reach out to your AWS account manager, reach out to the solution architect. If you have questions that are in any way impeding your AWS usage, there's somebody in AWS who will help you. And the first place to start is your account manager, and then they'll find either a TAM or a solution architect to help you out. I can't encourage you to do that enough. We'll continue to do these kinds of talks, but don't wait for us to answer questions on the webinar. Reach out to your AWS account team.
Sounds great.
All right. So
Thank you
I
very
think
much.
that's a wrap. We're good here. Thanks again for your time. We appreciate it.